Microeconomics students, we are on the second consumer utility model, the tabular or table approach. This approach is a little more of a grinded out type model, but it's also more practical because it produces a result that looks more like human behavior. And so we're going to introduce the formulas. We're going to talk about how to go through the approach, and we're going to go through the practice problem from Unit 2. Again, if you're still on Unit 1, you should not be watching this video. That's why it's not on a listed playlist at this present time. So let me share the screen. And now let's go to the PowerPoint slideshow and pick up where the last video left off, shall we? Now, suppose we were given some information about a consumer's preferences and the total utility, that's what capital TU stands for, they'd receive from buying and consuming various quantities of two goods during a fixed time period. Let's say a night out with friends at a local Tex-Mex restaurant, okay? We could get a basic utility table that would start off looking something like this, but you'll notice there's a couple of columns missing from each section. This person is choosing between nachos and margaritas, and so what it is the quantity of nachos consumed. A unit is like a small plate of nachos. No plates, one plate, two plates, three plates, etc. is what this is talking about. If you consume nothing, you get nothing. 0 utils, a UTIL, a util is a unit of utility. Like we measure inches for distance or millimeters or centimeters for measurement. We use pounds and kilograms. A util is a unit of utility. Now, one plate of nachos gives this person 25 utils. They might be asked a question after they eat the plate. On a scale of 0 to 30, how do you feel? Well, I'm about 25. And then they get a second plate of nachos. The total utility is 45 utils. The question is changed to, on a scale of 0 to 60, how do you feel? I'm about a 45. They eat a third plate of nachos. On a scale of 0 to 90, how do you feel? Etc. The idea here is, although we can't exactly draw a picture of what a util looks like, if you can understand that kind of qualitative survey, you've got the idea. And these are showing the total utilities received from consuming exactly this number of plates of nachos. For the margaritas, again, this might be a different scale. It might be a scale of 0 to 50, 0 to 100, 0 to 150, etc. But no margarita glasses, one glass full of margaritas, two glasses of margaritas, etc. All the times they drink this cocktail up to 6 times. And these are the total utilities and utils received as they drink them here. And you're going to notice a couple things. You're going to notice that each increase in total utility is smaller each time until it eventually plateaus. In the case of margaritas, it can actually go negative. We call this the principle of diminishing marginal utility. The notion here is that if you engage in the same activity repeatedly during a fixed short-run time period, it becomes less and less satisfying over time. You keep eating nachos, you get tired of them, and you get full. You keep drinking alcohol, you get drunk, and you may pass out or puke, in which case you have negative marginal utility. So the thing is, what we want to do is start with this data and see if we can put together a better way to use this to determine the optimal combination. Remember, optimization is our theme. Optimization in this case is maximum utility within the limits of the budget. And so first things first, 2 formulas to introduce you to. Marginal utility is the change in the total utility divided by the change in the quantity consumed. Now, we've got a table with a lot more than 2 rows, so we don't have 1 and 2. We have J and J minus 1. If row J is the second row J minus 1 is the first row. If row J is the third row J minus 1 is the second row. These are done in pairs going down in increments, but you have to start calculating marginal from the second row because the first row is 0, and you can't have a marginal until you've at least consumed something. But marginal utility in words is additional utility received from consuming an additional unit of a particular good. Like the first margarita gives this much utility. The second margarita, and only the second by itself, will give that much utility. The third margarita by itself will give that much additional utility. And so that's what marginal utility of the jth unit of a good is. Now, the marginal utility per dollar, think of the expression bang per buck. It's the additional utility received from spending one additional dollar on that additional unit, on the jth unit, if you will. That is equal to the marginal utility of whichever unit you're talking about, the first unit, the second unit, the third unit, divided by the price of exactly 1 unit. Be advised, once again, the letter J is called an index variable, which indicates row in the table, first, second, third, etc. And calculations have to start in the second row because the first row is 0, and you have to at least go from 0 to a positive number of an item in order to have a change in total utility or quantity. Now, I've also given some other information here. We're going to build the full table starting with that basic table, but we're given the following information. The price of an order of nachos is $2.50 for an order, and the price of a margarita is $4 per drink. I guess they're using cheap old tequila. And this person has $22 to spend. That's what's going on with that, because this is going to help us get to the next table. Now, a couple of other pieces of information. We're going to complete the table so we have 8 columns. We're going to calculate marginal utility and marginal utility per dollar for the nacho plates, and then marginal utility and marginal utility per dollar for, the margaritas. Now, when the table is complete, we start with the consumer's income and we spend it in a series of rounds. In each round, the consumer buys whichever product is available, as in the first margarita, the second plate of nachos, etc., that has the highest, please note the bold, marginal utility per dollar. Not the highest marginal utility, the highest marginal utility per dollar. By the way, I hope you all noticed that capital M, capital U, MU means marginal utility, and MU /$ means marginal utility per dollar. You have to be aware of what the symbols mean. Lots of alphabet soup in economics, after all. Now, here's the thing. Once you've bought that first margarita, it's no longer available for the rest of the time frame. You can't walk out of the bar, come back in 5 minutes later, and insist you're having your second first margarita or having just your first drink. Alcohol takes time to metabolize. Food takes time to digest. Once you've had the first of something, it's gone for good. The next one must be the second. Once you've eaten the second one, the first and the second are both gone. The next one you consume has to be the third. You cannot consume the same first item multiple times. That is silly. That makes no sense in the real world. The thing is, that's why we said after a product has been purchased and consumed in a certain round, it and its marginal utility per dollar are no longer available for the rest of the problem. In the event there are different goods available in the same round where the marginal utility per dollars are equal, the consumer will buy all of the goods that have the same highest MU per dollar that are available in that round if they have enough income. I have designed these problems so that if you ever have a tie in a single round, there will be enough income left to buy it. If you don't, that means you may have made a mistake a couple of rounds back. The process is repeated until all the income is spent, and then we figure out how much of each item did they buy and consume, and then what was the total utility of the combination. Now, this slideshow has got a problem you can look through on your own, and that's for the people that like to read things to themselves here. I'm going to actually go to our practice problem, which uses the same products but has different data. And so let's zoom in on this for a moment. I'm going to focus on the top table first of all. We have information about nachos and margaritas here. Notice the price of a plate of nachos is $3 per order. The price of a margarita is $2 per drink. And in this case, unlike in the problem in the slideshow, we have $18 to spend. And so we have to use this method that was described in the slideshow to determine the consumer's utility maximizing combination of the two products. I also want to calculate the total utility of the product. And you notice I have a table I've produced down below that's going to take us through the rounds, but we have to complete this table first. So we're going to start with the nachos. I have to highlight 2 rows because, again, let's go back to that formula for marginal utility. Total utility in row J minus total utility in row J minus 1 divided by quantity in row J minus quantity in row J minus 1. So change in total utility is 15 minus 0. That's 15 utils. Change in quantity is 1 minus 0. That is 1 unit. And so the marginal utility of the first plate of nachos is 15 utils. I'm going to talk through one more. 27 minus 15 is the change in total utility for the from the first to the second nacho. You say, why aren't you going back to 0? We already had the first one, so the change goes from unit 1 to unit 2, or from the first plate of nachos to the second. 27 minus 15 equals to 12 utils, and 2 minus 1 is equal to 1 unit. 12 divided by 1 means 12 utils. Now let me explain to you what these mean here. In this row where 2 plates of nachos have been bought and consumed, the total utility from buying and consuming both plates is 27 utils. However, just the second plate by itself provides 12 utils. Remember, marginal utility is additional utility received from consuming an additional unit of a product or a service. I'll talk through one more. Going from the second to the third plate of nachos, 36 minus 27 is a change in total utility. That's 9 utils. And then 3 minus 2, that's 1 unit. 9 divided by 1 is going to be 9 utils, just for, I emphasize, the third plate of nachos. Now, I'm going to go ahead and just put the rest of them in here, but you want to go through the process and make sure you calculate themselves. These are all the marginal utilities for the nachos. Now, excuse me a second here. I did not want to go there. All right. Now, we have to also do this for the margaritas. They have a different set of tastes for this person here, and so the total utility values are different. And so I'll talk about the first couple. 12 minus 0, 12 utils. 1 minus 0, 1 unit. 12 divided by 1 equals 12. 20 minus 12, 8 utils. 2 minus 1, 1 unit. 8 divided by 1, 8 utils. The pattern is the same as before. We're using the same formula, but then one person says, well, how come you're always dividing by 1? Well, in this table, delta Q happens to be 1 unit going down the rows. Now, that's a nice little convenience there, because that means that we don't have to worry about the division part so much, but be careful, because not all products are sold 1 unit at a time. Some are sold in quantities of 6 or 12, like 6 packs and 12 packs, for example. Some items are sold, by the ton versus by the pound. And so you're not going to have the same result or the same denominator every time. So you need to be conscientious about that. Always calculate the denominator in a marginal formula for a table. Now, let's talk about marginal utility per dollar. The price of an order of nachos is $3 per order. Notice the formula says take the MU in that row, divide by the price of 1 unit. That gives you the MU per dollar. Also, I want everybody to notice that every single cell in the table is formatted. If you just wrote 12, 8, 4, 2, 0, -2, guess what? You're wrong. Reason, you didn't tell me 12 of what, 8 of what, 4 of what. Format your numbers. That is mandatory. Now, notice here that MU per dollar is in utils per dollar, whereas MU is in utils. So, 15 utils divided by $3, that's the price of 1 plate of nachos. 15 divided by 3 is 5, but that's 5 utils per dollar. For the second row, 12 utils divided by $3 per order. 12 divided by 3, 4 utils per dollar. 9 divided by 3, 3 utils per dollar, etc., etc. And these are all the calculations here for the marginal utility. Now, some of you have had my macro or micro classes before, but say, how come these negative values aren't in red ink round parentheses? And that's because these aren't money. These are utility. The red ink round parentheses, no minus sign for negative values, only applies to things like economic losses or net export spending or net foreign income adjustment when you have negative dollar values. But these aren't dollars. These are utils and utils per dollar. So no red ink, no round parentheses, same color as everything else, gray pencil, black pen, must have a minus sign. Now, let's go over here. We don't divide by 3 here. Remember, the price of a margarita given up here is $2 per drink. So 12 utils divided by $2 is equal to 6 utils per dollar. $2, 4 utils per single dollar. 4 utils divided by $2, 2 utils per dollar, etc., etc., etc. And now we have a completed table. Now, one more thing I'm going to do here before we start the process. One of the things that was stated here was the fact that we have to have a completed table. And when the table is complete, our next step is to actually work through an iterative process. We have to do a procedure over and over and over again until something terminates it. And so let's go back over here to the slideshow to remind ourselves, when the table is complete, what do we do here? The consumer spends their income, the $18, in a series of rounds. The consumer buys whichever product is available, like the first plate of nachos, the second plate of nachos, etc., that has, in that round, the highest MU per dollar. Once a product is purchased, we have to cross it out. It's no longer available. If we have a tie, if the consumer has enough, they'll buy one of each. By tie, I mean highest MU per dollar available in a round is equal for 2 different products here. Process is repeated by the highest MU per dollar available over and over and over again until all the income is spent. You can't borrow money. You can't spend more income than you have. And so this is why I highlighted the MU columns in this table, because this is what we're focusing on. So round 1, our choice is either the first, and you have to be specific, ordinal number, as in first, second, third matters. First plate of nachos provides 5 utils per dollar. First margarita, provides 6 utils per dollar. Now, last I checked, 6 was bigger than 5. There's more bang for buck from the margarita. So in this first round here, the consumer makes a choice to buy the first margarita. Now, something else to remember, at the start of the problem, the consumer has $18.00 to spend. However, they now have to spend it. Now, last I recall, and again, you might want to double check at the top of the problem, the margarita costs $2. So over here, we have to do some arithmetic, and yes, you have to show the arithmetic. We subtract $2 from the margarita, and then we note they have $16 left. Now, because they have income left, the process continues, but I'm going to do one other thing here. I am going to put a diagonal slash across here because now that the first margarita has been bought, it is no longer available. So round 1 is done, on to round 2. Round 2, the choices. First plate of nachos, 5 Utils per dollar. Second margarita, 4 Utils per dollar. Remember, we already bought the first margarita. It's not available anymore. Last I checked in this universe, 5 is bigger than 4. So in the second round, excusez-moi here, I was not trying to select everything, just trying to select this one little cell, okay? The first plate of nachos is chosen. You have to indicate ordinal numbers. Don't forget that. And when you're working problem number 2 in the Unit 2 homework, you're going to create this table from scratch and fill it in here. This one I'm doing so it's easy to read. Now, a plate of nachos costs $3 per order, so we subtract $3 from $16, and that means the consumer has $13 left. So since there's money left over, the process continues. Remember, the process continues until, I repeat, until, there's no more income left. Now, round 3 is interesting. Remember, I told you a tie could happen. At the start of the third round, the second plate of nachos provides 4 Utils per dollar. The second margarita provides 4 Utils per dollar. It's equal maximum MU per dollar. How much money would the consumer have to buy 1 plate of nachos and 1 margarita? The guy could order it from the bartender or the waiter at that point in time, so it's not hard to order 2 things at the same time. $2 plus $3 equals $5. And notice they have $13. That's definitely $5 or more. So in round 3, you do not break it into 2 rounds. It's the same exact round, same time. This person buys the second plate of nachos and the second margarita. $13 minus $3 minus $2 is going to be $8 left. And notice we're itemizing this here. We want to keep track of which is which. And so the third round is done. And then let's just cross these out. They're now no longer available here. So let me change the border style. And yes, this thing is slow. I'm sorry. Okay. All right. Now we're on to the fourth round with $8 left. Third plate of nachos, 3 Utils per dollar. Third margarita, 2 Utils per dollar. 3 is greater than 2. That is the highest MU per dollar available. So this consumer is going to buy the third plate of nachos. I guess he's hungry, that he's thirsty, he's hungry and thirsty, that he's just hungry again. All righty, a plate of nachos costs $3, and so 8 minus 3 is $5 left. I do think we're almost done, but let's take a look here. Well. At the start of the 5th round, we have got 2 Utils per dollar for the third margarita and 2 Utils per dollar for the 4th plate of nachos. Once again, like in round 3, we have a tie. If the consumer has $5, and what do you know? They have exactly $5. They will buy both of these at the same time in the 5th round. And so I'm going to go ahead and slash these out, and then we're going to wrap up the problem in just a minute here. We're going to cross out those 2 values because those have now been bought. Okay. We're going to make sure in our table down here, we itemize the fact that the 4th plate of nachos and the 3rd margarita have been bought. 5 minus 3 minus 2 is equal to $0, and the process is completed as far as determining this. Now, this looks like actual human behavior. Somebody goes into a bar, it's been a tough day at work, give me a margarita, man, extra tequila and extra lime, extra salt too, okay? Glug, 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 glug. About halfway through, you know what, I'm hungry, give me a plate of nachos too, okay? Chomp, 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 glug, glug, glug. Okay, you know what? I'm still hungry and thirsty. 1 more margarita, 1 more plate of nachos, please. Coming right up, sir. This looks like actual human behavior spaced out over a couple of hours, somebody hanging out at a bar, having some drinks and having some snacks. This looks like actual human behavior, But then people say, well, it takes so long. Well, this is modeling a couple of hours worth of behavior. What do you expect it to be? It doesn't take a couple of hours to do the problem, though. But now the last thing we have to do is we have to summarize this thing. And the first thing we have to summarize is what is the optimal combination? In other words, which mixture for this consumer of margaritas and nachos maximizes their total utility within the $18? Well, we take a look here. They bought a total of 4 plates of nachos. Look back up there. 4 of them are slashed out. They bought 3 margaritas here. And so the next thing we're going to talk about here, excuse me, just one second here, as I do the big reveal. The optimal combination is 4 orders of nachos and 3 margaritas. Now, the next thing we have to do, or the last thing we have to do, is calculate the total utility for that combination. And for that, we got to go over to this TU column, y'all. Class, we don't use MU to calculate total utility. We already know, I repeat, we already know here that they bought 4 plates of nachos, and the total utility from all 4 combined is 42 utils. For the margaritas, we know they bought 3 margaritas, and the total utility for the 3 margaritas here is 24 utils. Okay, and so to calculate the total utility, we just got to add those 2 numbers together, and that takes care of it. The total utility of the optimal combination, and yes, you got to share your work for this part, y'all. Sorry, that's just the way it goes here. Is equal to 42 utils plus 24 utils, which equals a total of 66 utils. I'm going to adjust the margin so it's all on the same line here. Better. Class, I want y'all to notice when we state the optimal combination is not 4M or 4N, 3N. We write the words here. You use your words like your kindergarten teacher told you to do. You state how many of each item it is, and you write the number of words out. Okay, 4 plates of nachos, 3 margaritas. That's number 1. And then you show the math work for calculating the total utility of 4 nachos plus 3 margaritas is 42 utils plus 24 utils, which equals a total of 66 utils. Now, for those of you out there who are saying, come on, how do you know that that's optimal? Well, let's think of all the other combinations that cost $18. 6 plates of nachos, 6 times 3 is 18, would be 42 utils. 42 is less than 66. That's not optimal. The person could have bought 6 margaritas and 2 plates of nachos. 6 margaritas cost $12. 2 plates of nachos cost $6. 12 plus 6 is 18. That's 24 plus 27. That's 51. That's less than 66 utils. Students, any other combination that costs $18 or maybe slightly less, like $17, is not going to be max utility. For those who want to argue about 17, 5 plates of nachos plus 1 margarita. 45 plus 12 is 57, still less than 66, and there is no utility assigned to that $1 they didn't spend. It's money they get to keep, but there's no utility assigned to it because they didn't spend it on anything. Students, this combination is optimal. It's max utility, but still within the limits of the budget. That is the one that is chosen. And so problem number 2 on the Unit 2 homework for microeconomics has a similar problem to this one. And so I would like everybody to please make sure they take some time to work it here. This problem here in our video is being covered in class, okay? But just the same, I wanted to have a video of it so people could go back through it. And also, if I teach an online course, I'm going to use them for them as well. So hopefully this sheds some light on the table approach and it produces a nice result. Both models are good for different reasons. I tend to like the level curves model just because I've got a math background, but as somebody who lives in the real world, I appreciate the table approach. And man, don't a lot of us have to work spreadsheets. Thank you all very much. Have a great day, and I'll see y'all later.